This will be for the Khan assignment, transforming random variables. So for this assignment, you want to remember, if you add or subtract from the data points, the mean will change, okay? And if you multiply or divide the data points, both the mean and standard deviation will change. In other words, adding or subtracting to the data does not change the standard deviation. So for the standard deviation, there's no change when you add or subtract. All right, some of these write-ups may not even be necessary. It says a company offers a renter's insurance policy, costs the customer $70 per year. Company makes a payout of $10 grand to the customer if they are a victim of theft. Company sets this probability of theft at 0.002. Let X represent the company's profit. All right. So there's really unnecessary information here. X is the profit. Okay, the mean is given right here by this Greek letter, mu. All right, this is mu sub X, the mean of X. And this is sigma, the standard deviation. That's sigma sub X. All right. The company is increasing the policy by an additional $10. Let Y represent their profit from one of the higher price policies. And they want to know the mean and standard deviation of Y. Okay, so they say that they are just adding, they're increasing the price of the policy by 10%, by $10. So they are just adding $10. So if you add $10 to the price, obviously their profit is going to be $10 more. Okay, we said at the beginning, adding changes the mean, but not the standard deviation. So to add $10, the mean will definitely change. So you just add $10 to the mean, and 50 plus 10 is 60. All right, but adding or subtracting does not change the standard deviation, so this value remains unchanged. So the new mean is 60, the new standard deviation is still 447. 60, click tab, and then type 447. All right, Marcos owns and operates a shuttle service that runs every hour and transports customers. Let X represent the number of customers on a randomly chosen trip. Based on previous data, here is the probability distribution of X. Okay, X is the number of customers. All right, suppose that each trip costs Marcos $1 in fuel, regardless of how many customers, and each customer on a trip pays him $10. Let Y represent the net gain from a randomly chosen trip. Okay, Y is basically how much money he makes. So it costs him $1 in fuel, regardless of how many customers. All right, so he loses $1 because it costs him $1 in fuel. And each customer on a trip pays him $10. Okay, X is the number of customers. The average number of customers is 2. All right, and each one pays him $10, so it's going to be plus 2 times 10. Because there's 2 customers and each one pays him 10. So -1 plus 20, that's going to be -19. All right, that is the new mean. I'm sorry, positive 19. 20 minus 1, positive 19. All right. Now for the standard deviation. And you know what? Let me just fix this Y here. Okay, that will be the mean of Y, positive 19. And then the standard deviation of Y. Remember we said for standard deviation, adding or subtracting does not affect it. Okay, so I'm not going to add or subtract anything here, but we still want to multiply this number times the 10. All right, so it's just going to be 1 times 10. because each customer pays him $10. So we have 19 and 10. So notice I used the same formula twice, but I left off the -1 for the standard deviation. All right, I'm going to skip the write-up on this one. Just looking at the table, R is the number of ringers, okay, and they give us the mean of R and the standard deviation of R. So a lot of the stuff they're giving us on the table is just unnecessary, okay? You don't need the probabilities here at all. All right? You just need the mean and standard deviation. So Nikola gets 3 points for each ringer that he scores. Let X represent the number of points that he gets for ringers in a round. Okay? R is the number of ringers, and he gets 3 points for each one. So for the mean, we're just going to multiply it by 3. Okay, 0.3 times 3 is just 0.9. And we said at the beginning, multiplication does affect the mean, okay? And we also said at the beginning, multiplication affects the standard deviation. So we're just going to do the same thing to the standard deviation. Okay, 0.56 times 3, that's going to be 8. Carry the 1, that's going to be 1.68. All right, let me double check that on the calculator. Yes, it's 0.56 times 3, it's 1.68. Okay, so it's just going to be 0.9. Hit tab, and then 1.68. So if I were to give you a piece of advice for this exercise, you want to apply the same formula to the standard deviation that you use for the mean, excluding the addition and subtracting part. All right? So use the same formula, but any plus minus, just exclude that. All right, one more. So just looking at the table, X is the profit in dollars. Okay, they give us unnecessary information. We do not need the probabilities here. All right, really, we probably don't even need this part. But anyhow, here is the mean and standard deviation. And it says the company is going to run a promo where customers get $2 off any slice of pizza. Assume that the promo will not change the probability that corresponds to each size. All right, $2 off any slice of pizza. All right, and Y is going to be the new profit. Let's see. All right, so it's $2 off any size pizza. And this is the mean or average profit. Okay, if they're going to give $2 off any size, it's just going to be minus 2. Okay, so 8.56 minus 2 is going to be 6.56. Now we said apply the same formula to the standard deviation, excluding the plus minus part. So do we want to subtract 2 from standard deviation? No, we don't. Okay, the standard deviation does not change. So that's it. 656 and 277. 6.56, tab 2.77. All right, so just make sure your answer is correct. All right, so X was the profit, and they gave $2 off. So now they made $2 less on each pizza. That's why I subtracted 2, but subtracting does not affect standard deviation.